First query after deploy took 90 seconds, then timed out. OpenAI dashboard showed 4,000 embedding calls in 1 hour. The culprit? MemoryVectorStore reindexing on every cold start. The article uses stream text from the AI package. In AI Software Development Kit v5, stream text returns a stream result object, call to text stream response, to get a response. Earlier versions use streaming text response directly. Ensure you're on AI at 5x and at AI Software Development Kit /OpenAI at 1x for the shown syntax. The article mentions hash deduplication, but doesn't show the caching logic. Here's a concrete implementation using a Redis set to track already indexed hashes, avoiding re-embedding unchanged chunks. The article stresses using the same embedding model for index and query. A common production mistake is updating the embedding model, e.g., from text embedding 3 small to text embedding 3 large without reindexing, causing dimension mismatch or degraded retrieval. Always reindex when changing the embedding model and pin the model version in your CI configuration. Let's break down how to build your own AI coding assistant with Next.js 16, OpenAI and RAG 2026 stack, how it works, and the exact mistake behind that failure. RAG stands for Retrieval Augmented Generation. It retrieves relevant code chunks from your codebase and feeds them to an LLM, so the answer is based on your actual code, not generic internet knowledge. The pipeline has 2 phases. Indexing runs in CI on every push, extracting code chunks with tree sitter and generating embeddings. The API route only queries pgvector and streams the response, never embeds in the request path. Tree sitter parses your code into an abstract syntax tree. We extract complete functions, classes, and methods, and prepend the file's import statements so the LLM understands dependencies. Each chunk is hashed to avoid reindexing unchanged code. Here's the indexing script. It walks your TypeScript files, parses each with tree sitter, extracts functions and classes, prepends imports, hashes the content, and stores the embeddings in pgvector. The hash is used as the document ID, so reindexing the same file updates rather than duplicates. For streaming, we use the Vercel AI Software Development Kit. It handles server-sent events, backpressure, and token counting automatically. We set temperature to 0.1 for deterministic code generation. Higher values cause hallucinations. This API route handles the query. It rate limits per IP, performs similarity search with a relevance threshold of 0.78, caps context to 20K tokens using tick token, and streams the response. The system prompt instructs the model to answer only from the provided code. Pure vector search misses exact symbol names. Hybrid search combines BM25 keyword score with vector cosine similarity. In pgvector, we use tsvector for keywords and less or equal for vectors, ordering by a weighted sum. This SQL query performs hybrid search. It calculates both vector similarity and keyword relevance, then orders by a weighted combination. The threshold of 0.78 ensures only relevant results are considered. This is the same issue we highlighted at the start. Here's exactly why that happened. The team used MemoryVectorStore, which lives in process RAM. On every cold start, each of 20 Vercel instances re-embedded the entire repo. That's 4,000 embedding calls in an hour, costing $340 and causing 90-second timeouts. Using MemoryVectorStore and serverless causes full reindex on every cold start across 20 Vercel instances, wasting cost and time. The fix moves indexing to a GitHub action and stores vectors in Neon pgvector, so the API route only queries. The fix was to move indexing to a GitHub action that runs on push. Vectors are stored persistently in Neon pgvector. The API route now only queries, taking 45 ms. Embedding costs dropped from $340 month to 40 cents month for incremental updates. MemoryVectorStore stores vectors in RAM, which is lost on every serverless cold start. Each instance re-embeds the entire repo. For a 2,000 file repo, that's 17 cents per instance. With 20 instances, you get a $340 bill in an hour. Using raw fetch misses backpressure and error propagation. The AI Software Development Kit handles SSE framing, retries, and usage tracking automatically. Always use stream text to text stream response in 2026. Never concatenate user input into the system prompt. This creates a jailbreak vector. Instead, keep user input as a separate message with role user and inject context as separate system blocks. To debug, first query pgvector directly to see if embeddings exist. If empty, CI indexing failed. Check your API route for any index repository. Calls, that's a red flag. Use TickToken to calculate token counts and ensure context capping works. Let's run through some common interview questions. Why can't you use MemoryVectorStore in serverless? It stores vectors in RAM, lost on cold start. Each instance re-embeds the repo. Explain hybrid search for code RAG. Combines BM25 keyword score plus vector similarity 0.7/03 for 95% plus recall. How to prevent indexing secrets? Respect. Git ignore, add explicit dentalist, run git secrets scan before embedding. And a few frequently asked questions. Can I use local models? Yes, replace OpenAI with Llama via AI Software Development Kit, but quality drops till to 25%. What's the monthly cost? Day with caching and GPT-4o Mini for simple queries. Why treesitter over Lang chain text splitter? Treesitter preserves function boundaries, 98% recall versus 60%. Let's recap the key takeaways. Treesitter plus pgvector plus AI Software Development Kit plus Upstash. Never MemoryVectorStore in production. Index offline in CI, query online. Hybrid search for code retrieval. Ready to go deeper? Up next, the new T3 stack in 2026, then how to fix Next. JS 16 hydration errors once and for all, then Next. JS 16 plus React 19 complete migration guide and advanced error handling and logging in Next. JS 16 applications. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.